Hello and welcome to this lesson video for applications of graphing quadratics, and in particular we're focusing when our equations are in vertex form. So let's get started. We've got a pumpkin chumpkin contest that we're going to talk about. We've got this launcher that's going to launch a pumpkin on a parabolic arc at a velocity of 35 feet per second. The path of the pumpkin can be illustrated by this equation here that's in vertex form. And the first question asks us, what is the maximum height of the pumpkin? So I went ahead and got a graph for us of this equation just so we have a visual as we're talking. And so obviously you can easily tell that this vertex here is the maximum height of our pumpkin, and we can tell by the graph that it reaches at 16 feet. But you know, I'm not going to always give you graphs, so we need to know how else to think about this. The key is to focus on the vertex and to remember that in vertex form, we take the opposite of this guy that's inside, and so that's why the x value there is +1, and then this guy, as he is, gives me the y value for my vertex. So my vertex is simply 116. Also, it's important to remember that with what we're talking about, the x value represents time. So after 1 second, the pumpkin is 16 feet, I believe we talked about. Yeah, feet in the air. So to answer what's the maximum height, based on the vertex, the height being 16 feet, the max height of the path of our pumpkin is 16 feet. So let's continue. The next question says, how long will it take for the pumpkin to reach this max height? Well, I kind of gave it away on the last slide. Again, we focus on the vertex because that's where the highest point is happening. And it takes the pumpkin 1 second to reach that highest height of 16. So that answers their question. The time to reach the max height is simply 1 second. And that, again, that came straight from the vertex. This time using the x value. So we've got some more questions. The third question about this path of the pumpkin says, how long will it take the pumpkin to return to the ground? Well, we need to think about what it is it's asking me for. To return to the ground, that means my y value, my height, my h of t, should be 0 because ground level is 0. Okay? So I'm going to plug into the equation 0 for h of t, and then I'm just going to proceed to solve using the square root method, where I need to get my parentheses squared alone. So the first thing would be to subtract 16 to both sides. And then, you know, we talked about parentheses squared, it's like a jail. Nothing wants to get in, and nothing can get out until I get rid of the square. So this -16, you know, sometimes folks want to distribute, but you can't. It doesn't want to get in. So another way to undo that multiplication is to divide. So we're going to divide both sides by -16. And notice that on the left-hand side, that results in a +1. But here's where we talked about that jailbreak. We're going to spring t minus 1 out of that jail by getting rid of the square through a square root. So we square root both sides and take a look at what happens. We end up with plus or minus 1. You know, if you evaluate or simplify the square root of 1, it's just a 1. But remember, it's plus or minus. Just because the square root house went away, plus or minus is still guarding that guy, that 1 that's coming from that square root. So when we have this intruder, this +1 that needs to come over to get t by itself, remember we've had this discussion, it goes in front of the plus or minus sign because the plus or minus won't let it by. So since I have just nice numbers, we've also talked about branching, and we need to do 1 plus 1, 1 minus 1, and we get 2 t values. Now obviously my pumpkin starts at time 0, so to answer the question when it will return, that value doesn't make sense because that's when it started. So after it travels and it lands, it's landing here at 2 seconds. Well, I haven't used my mouse to type, so I won't type seconds. But we should say t would equal 2 seconds. Okay. I think we've just got one more question about this pumpkin. It says, find the time or times when the pumpkin will be 12 feet in the air. So again, you won't always have a visual like I've been providing you. So we've got to think about what it means. It's asking when will the pumpkin have a height of 12 feet? So h of t should equal 12. So what I do is I plug in 12 for h of t. So my equation is now set equal to 12. And then I just kind of follow the same process as before. Square root method, subtract the 16. Again, I can't distribute, so I have to get rid of that multiplication through division. Now, be careful, we seem to miss this a lot. When you divide two negatives, they just turn positive. So I'm really just taking the square root of, well, if I reduce 4/16, that reduces to 1/4. Okay. And again, I want to get t minus 1 out of jail, so I'm going to do a jailbreak by taking the square root on both sides. That way I get rid of that square. Okay. And the square root of that fraction, remember, we just think about square root of the top number, square root of the bottom number. And don't forget about that plus or minus. And so I'm going to work with this a little bit more. I want to simplify those radicals because those are actually kind of easy radicals. Radical 1 is just 1 and square root of 4 is simply 2. So this is a fraction, is just 1/2. And so I need to bring over this intruder, but remember plus or minus won't let him by. So it's going to be 1 plus or minus that half. And then I need to branch. So 1 plus a half and 1 minus a half. And so the 2 times, I end up with 2 real times here. The 2 times that the pumpkin will be 12 feet in the air are when it's after a half a second has passed and after 3 halves have passed. So think about it. It's going to hit 12 feet as it goes up to its max height, and then it's also going to drop back down to 12 feet. Okay? So you can see how it matches our 1/2 and our 3 halves, like we talked about in our solving. Okay? So that's going to do it for us with this pumpkin chunkin question. So that finishes this video, and make sure that you ask me for the worksheet to continue on. Keep learning and have fun.